Hey everybody, today we're going to do some more stuff with similarity and with proofs because that's what you have been asking for. So if we look at example 1, it says solve for x, and they give me a similarity statement. It says triangle ABC is similar to triangle LKJ. So when I get a similarity statement, I know that A is congruent to L because they're in the same spot. So angle A is congruent to angle L. Angle B is congruent to angle K. And angle C is congruent to angle J. Having the congruency marks in there will help you when you're trying to set up your ratios. Now I want to solve for x. So here if I look at my two triangles, 35 is in the same position as 84. So I can set up that ratio. So 35 over 4. And that's going to equal 4x over 48, since those are in the same position. When you have proportions set up like this, you can cross multiply to solve. So I'm going to do 84 times 4x, and I'm going to set that equal to 48 times 35. 4x times 84 is 336x, and over here I'm going to get 1680. To solve for x, I'm going to divide both sides by 336, and when I do that, I get x is equal to 5. What I would like you to do is go ahead and pause the video and try to see what you can do on number 2. This is the same sort of thing that we did in week 1 of the continuity of learning folder. So if it helps you, go back and look at your week 1 notes and see if you can do this example on your own. So if we look at example 2, my similarity statement is that triangle SRT is similar to triangle ERF. So that means that angle S is congruent to angle E. Angle R is congruent to itself. That makes sense since we have vertical angles there. And then angle T is congruent to angle F. Now that I have that set up, it's going to be easy for me to set up my proportions. So here I can see, you can start with any triangle that you want. You'll notice on example 1, I said this triangle over this triangle for my first ratio. So 35 over 84. So I do the same thing with second up my other ratio. That means I have 4x over 48. Once you choose to start with the top, you have to choose a top for both fractions. Same thing over here. If I choose to start with the bottom, then I have to choose to start with the bottom for the other fraction. So here, I can see that if I choose this 9 to start with, right here, that's going to go with this one right here, 54. And I know that because 9 is in between the 2 congruency marks and the 3 congruency marks. And 54 is in between the 2 congruency marks and the 3 congruency marks. So that means this 9 will be over 4x plus 10. Once you have your proportions set up, then you're going to do cross multiplication. So here I'm going to do 9 times 4x plus 10 is equal to 9 times 54. You'll notice that because I have two terms here, I use parentheses. So that 9 is being multiplied by both terms, so you have to be sure that you distribute. So when you do that, you get 36x plus 90 is equal to 486. Now I can solve for x. So I'm going to subtract 90 on both sides and get 36x is equal to 396. Divide both sides by 36 and get that x is equal to 11. If you're having questions and you're still struggling with setting up these proportions and using similarity to solve for a variable or to find a missing side, send me a message in Schoology. Send me a specific question that you're struggling with, something that you don't understand, so that I can help you work through that. Alright, so now we're going to look at some proofs with similarity. Whenever you're proving something, you always want to start with your given statement. So my given statement is that line segment NO over line segment QO is equal to line segment MO over line segment PO. That's given. So our given statement tells us that two sides are proportional. So that this side over this side is proportional with this side over this side. So we know that it's proportional. So since we know that two of our sides are proportional, we can either prove that the third side is proportional, because then if all three sides are proportional, then we can say that they're similar. Or we could find the angle in between them to use side, angle, side similarity. It's going to be easier to prove that the angle is in between them is congruent. And if I look at that, the angle in between those sides that we were talking about are these pair of angles right here. And these pair of angles are something special. They're vertical angles. So now we know that angle NOM is congruent to angle POQ. And that's by vertical angles. So now we know that this side is proportional with this side, and this side is proportional with this side. So if the two sides are proportional, then we know that we have similarity. So we can say that triangle MNO is similar to triangle PQO by side, angle, side similarity. While you're completing these proofs, you might find it useful to have your similarity statements from the last set of notes in front of you. That way you can figure out which type of similarity you have to be able to prove them. So when I look at this next example, the given statement is that line segment MQ is parallel to line segment OP. Remember these two lines right here means parallel. And those parallel marks are already on our diagram for us, so that helps. I'm trying to prove that these two triangles are similar. So I need to look for either sides or angles to help me do that. They don't give me any information about the sides, but right away I notice that I have a pair of vertical angles, so maybe that can help me. So I'm going to go ahead and say that angle MNQ is congruent to angle ONP by the vertical angles. Alright, so because I don't have any information about any sides, I know I can't use any of the similarity statements about that. But we have another similarity theorem, the angle angles. And so if I can find something else about another angle, then I can say that these two triangles are similar by AA similarity. Well, because I know that these are parallel lines, then here I have transversals that cut through them. So then I can say that either these are alternate interior angles, or you could say that these are alternate interior angles. You could use either statement to say that you have similarity between these two triangles. I'm going to use these as my alternate angles, but you could also use angles P and angle M, however you want to do it. So I'm going to say that angle MQN is congruent to angle NOP because they are alternate interior angles. So what we've just said is that here we have an angle and here we have another angle. So I can now say that triangle MNQ is similar to triangle PON by angle similarity. If we look at our last example, our given statement is that line segment AE is parallel to line segment BD. And that's given, so I've written that down. So again, no information about any sides. So let's see if I can figure anything out about the angles. Well, because I know I have parallel sides, or parallel lines here, I can say that angle A is congruent to angle B. And that's because they're corresponding angles. So angle A is congruent to angle B. And for the same reasoning, I could say that angle E is congruent to angle D because they are also corresponding angles. Well, if I have two pairs of angles that are congruent, then we've just proven that these two triangles are similar by AA similarity. Now, if you recognize that these were corresponding, and then you recognize that C is congruent to itself by the reflexive property, then you could have used this statement, and then you could have also have said angle C is congruent to angle C by the reflexive property, and you wouldn't have had to use this one. Or you could have used these two. Angle C is using the reflexive property and ignored these two. So lots of different ways that you could have proven this statement as well. As you guys are working through your practice assignments, as you have any questions at all, please send me a message through Schoology so that I can help you.